All right, recording, cool. Hello, everybody. This is going to be section 2.3, quadratic functions. So we will be graphing quadratic functions. The graph of a quadratic function is called a parabola. That's what these lovely U-shaped or V-shaped graphs are. And we will also be exploring the vertex form of a quadratic function as well. So getting into it, a quadratic function is a second degree polynomial because the highest power or degree is 2. And your standard form of a quadratic function is ax squared plus bx plus c, where the leading coefficient a cannot be 0. Okay, so based off of that standard form, you have two types of parabolas. You have a parabola that will open up. You have a parabola that will open down. If your parabola opens up, this means that the leading coefficient is positive. This means that A is positive, right? A is positive, and if it's positive, it opens up. Okay. The second type is if A is negative. If A is negative, the parabola opens down. So if your leading coefficient is negative, it opens down. Okay, so a couple of characteristics of parabolas, whether they open up or open down. One of the main points of a parabola is called the vertex. So you see there, the vertex, that is the middle point, that is the main point of your parabola. And it is a coordinate x, y, but in order to give it a special notation to make it look different from an ordinary coordinate, we always label the vertex as HK. It's still XY, but to denote that it's the vertex, we make it HK. Okay, and again, the other characteristics, you will always have a y-intercept on your parabola, and then we come to x-intercepts. So depending on your function, you may have 2 x-intercepts, you may have 1 x-intercept, or you may have no x-intercepts. It all depends on your function. So you could have 2 x-intercepts, 1 x-intercept, or no x-intercepts. And you will always have an axis of symmetry. This is the line that cuts straight through your vertex, straight through the parabola, and it allows you to reflect points across it. So you always need 3 points to graph a parabola. You need a vertex, and you need a point to the left of the vertex, and a point to the right of the vertex. Well, let's say that you had a vertex and you had a random point up here. Well, in order to find that third point, you could use the axis of symmetry to reflect it across, and you get your third point, and all you have to do is connect your points to graph it. That's it. Okay. And just like I said, it doesn't matter if it opens up or opens down, you have the same characteristics. You have a vertex, you have a y-intercept, and again, you may have 2, you may have 1, or you may have none x-intercepts. And then you have your axis of symmetry. Okay, another thing to talk about is domain and range of our parabolas. Since our parabola is based off of a quadratic function, the quadratic function is also a polynomial. So the domain of all polynomials, of all quadratic functions, is all real numbers, negative infinity to infinity. But now the range for a parabola that opens up will start at the y value or the k value of the vertex. So it will start at the k value of the vertex, and it will head up towards infinity, because that's where these tails are headed. They are headed up towards infinity. So your range goes from k to infinity. Well, you could also say just y to infinity, if that k throws you off. Okay. If your parabola opens down, well, your domain is still the same. Your domain is still negative infinity to infinity, and your range is different now. So these tails are headed towards negative infinity. So our range will go to negative, start at negative infinity, and head up the y-axis and stop at the k value of our vertex, or the y value of our vertex, right? Negative infinity to y. And look at the notations. The y or the k has a bracket. That means that that y value is included. So the y value is included. And to say it again, infinity never gets a bracket because we have no idea what an infinity is. So infinity always gets a parentheses. Okay, so another characteristic that's not on here is, well, if your parabola opens up, this means that the vertex becomes a minimum on the graph. So you get a minimum. This would be a minimum at the k value of the vertex, right? So minimum at k. And if your parabola opens down, well, this becomes a high point. This becomes a maximum. And you'd have a maximum at k. So these are all the characteristics of our parabolas, whether they open up or open down. And the table below shows us everything I covered, if I covered all of it, right? Okay, so we see that we have two different equations here. So the first equation you see here is called the vertex form, which we will be creating on the examples. And the easiest way to create the vertex form is to find h and k and plug them in. And the way we do that is by using this formula here. So one way to find the vertex is to use this formula. H equals negative b over 2a. That means you take the b value and the a value from the standard form and plug them in. And then to find k, well, whatever you found for h, you plug into the function to find k. Okay. A lot of circles there. So that's what we're going to do. So we're going to go from standard form to vertex form by finding h and k. And then if you have h and k, well, some information comes after that. Your axis of symmetry, your line of symmetry is given by the h value. So if you know the h value of your vertex, you know the value for your line or axis of symmetry. And you guys see that it is the same formula for h. So if you know your h value, you know the value, you know the x value for your line of symmetry. Okay. All right. To find a y-intercept, we've done this before. To find a y-intercept, you know that you let x equal 0 and you solve for y. To find an x-intercept, we know that you let f of x equal 0 or you let y equal 0 and you solve for x, whether it be by factoring, square root method, quadratic formula, whatever works for us. Okay, and then here's what I talked about earlier, maximum or minimum. Your quadratic function has a max. If your parabola opens down, that means that your leading coefficient is negative, and your parabola has a minimum if your parabola opens up. This means that your leading coefficient is positive. That's everything that we explored up here. So if it opens up, you have a minimum. If it opens down, you have that maximum. Okay, and then range, talked about that as well. If you have a maximum, the range is y is less than or equal to the max. So that means that your range is negative infinity to the k value of your vertex, which is your maximum y value. And if your parabola opens up, then it goes from your k value to infinity. So that means that your y value or your k value is greater than your min. Okay. Sorry, not your k value. This means that every y value is greater than your minimum. There you go. Okay. All right. So those are all the characteristics of a parabola, of a quadratic function. And let's go ahead and practice on the next page. Okay. So Here, given a quadratic function, we want to find the vertex form, we want to find the vertex, we want to find the intercepts, we want to find the maximum or the minimum, range, domain, and of course, graph it. But in order to find the vertex form, we have to find the vertex first. So we're just going to switch these two up in the rotation. Okay, so starting off, we'll say that we'll call this A. We're going to look for the vertex. So vertex. And remember to do that, we use a simple formula. H equals negative B over 2A, and K equals F of H. Okay, and you get your A and B values from your quadratic function. So if you label them already here from the quadratic function, A is 1, B is negative 4. We don't really need C here. We just need A and B. Okay, so plugging in, this means that H equals negative B. So it's going to be negative 1 times negative 4 over 2 times A, which is 1. Then you get 4 over 2, which gives us 2. So this is the H value of your vertex. Now to find K, well, you just take that 2 we found and plug it into the function above. So you'll have F of 2, and you're going to plug 2 in for every x to the function given above, which means you'll have 2 squared minus 4 times 2 plus 3. And then calculate, what's that? 4 minus 8 plus 3. 4 minus 8 is negative 4, and negative 4 plus 3 is negative 1. There we go. And we have our vertex. Our vertex is now the coordinate to negative 1. So there we go. We have our vertex. Okay, which means we can now move on to the vertex form. All right, so we'll say B, vertex form. Which is f of x equals a times x minus h squared plus k. Okay, and all we have to do here is plug in h and k from what we found in step A. And you also will plug in the a value. So this one's nice. Whatever the a value is on your quadratic function, that is also the a value that goes in your vertex form. So very nice how that works out. So if we plug our numbers in, you'll have f of x equals 1 times x minus, and when we plug in, I'll do parentheses. So I'll say x minus parentheses 2 plus parentheses minus 1. So remember that this was h and that was k. Okay, cleanup time. Oh, don't forget the square there. Cleanup time, you get f of x equals 1 times x minus 2 squared minus 1. That's it. That is your vertex form. So there's your vertex form. Okay, so we have vertex form, and then we will get into intercepts. So we'll do x and y intercepts. So that's next. Let's see, we're good there. So C, we'll do intercepts, and I'll start with the x-intercept. So with the x-intercept, we let f of x or y equals 0. And you have two choices here. You can set the original function equal to 0 and solve for your x-intercepts, or you can set your vertex form equal to 0 and solve for your x-intercepts. So what am I going to say? So If the original function is factorable, then set it equal to 0. But if it is not, then you are going to want to set your vertex form equal to 0. So that's something we want to check out. So let's look at the original function, which is x squared minus 4x plus 3 equal to 0. And if this is factorable, then we'll go from there. If it's not, we will use the vertex form. So this means that here we know that minus plus means x minus a number, x minus a number equal to 0. And then we know that the only factors of 3 are 1 and 3. And let's see if this works out. So just a quick check. X times x is x squared. Negative 3x minus 1x is negative 4x. And negative 1 times negative 3 is positive 3. So this checks out. This is factorable. Again, if it's not factorable, you set the vertex form equal to 0 and solve for x using the square root method. So here it's factorable. You get x equals 1, x equals 3. There we go. There's my x-intercepts, and I'd label them as coordinates 1, 0, 3, 0. Okay. Just a quick reference on using that vertex form, just to show you guys, because again, multiple methods. Let's say you did set that vertex form equal to 0. X minus 2 squared minus 1 equal to 0. You add that 1 over, and you get x minus 2 squared equals 1. Then you square root both sides, and you get x minus 2 equals plus or minus 1. Add the 2 over. X equals 2 plus or minus 1. All right. Which means now you get your two answers. You get 2 plus 1, 2 minus 1. So 2 plus 1 gives us 3. 2 minus 1 gives me 1. Same thing we have there. So again, if it's factorable, don't worry about using vertex form. If it's not factorable, do vertex form. Okay. Or you could bust out the quadratic formula, which we don't want to do unless we really have to. Okay, cool. All right. Next is your y-intercept. So for your y-intercept, these are really nice. Y-intercept, you let x equal 0, and all you have to do is plug 0 into the original function. This one you want to use the original function because it's less work. So you plug in 0, that becomes 0, that becomes 0, and you're left with 3. That's it. Easy. Y-intercept is always easy. Okay. So this means that when you plug it in, you'll just say f of 0 equals 3. And my y-intercept is going to be the coordinate 0, 3. Okay. So now we have all the information we need to graph to find the rest of the information. So first off, let's plot our vertex. Our vertex is at 2, -1. So that's 1, 2, here, -1. There's my vertex. And then my x-intercepts are at 1 and 3. So here I have at 1, and here I have at 3. And right there, we have enough information to graph. I have a vertex, I have a point to the left of it, I have a point to the right of it. And then you can plot your y-intercept since we found it. It's at 0, 3, which is right there, and just connect. But here, you can use that axis of symmetry if you want to reflect that y-intercept. So remember that the axis of symmetry cuts straight through the vertex. Straight through the parabola. So this is how your axis of symmetry works. If this point is 2 spaces away, then your next point will also be 2 spaces away. There you go. And now we have more than enough points to graph. So if we graph this, you just connect up and to the right, up and to the left, and there you go. It's graphed. And now answer the rest of the questions. Domain, we know, is negative infinity to infinity. Range, we know since it opens up, your range will start at the k value, the y value of your vertex. So your range starts at -1 and head towards infinity. And since it opens up, you have a minimum at y equals -1. There we go. And just to label your axis of symmetry, it is x equals 2. That's your axis or line of symmetry. Cool. All right. And those are all the steps to graph your quadratic function. Okay. All right. Let's run through this one because this is going to be one that opens down. Might as well have it. You can also watch these lectures in 1.5 or 2 times speed. I know, because it's a lot of information. So let's run through this again. All right. So A, we're going to find the vertex. And over here, A is -5, B is -40. And here we'll go. H equals -b, so -40 over 2 times A, which is -5, and you get +40 over -10, which gives you -4. And then K, you do, here are functions labeled as S, so you'll say S of -4, plug in -4 for everything. Just making sure. I know I'm doing turbo math, but don't want to make a mistake. All right, -5 times 4 minus 40 times -4 minus 78. And that is, oh, can't forget the square. Okay. And then, I didn't forget the square in the last one, right? No, we did it. Okay. All right. So that'd be -5. See, calculator comes in handy here, right? Just punch all this in. That's 16. Let's see. -5 times -4 squared minus 40 times -4 minus 78. And we get 2. So our vertex is -4, 2. Okay, which means move on to the vertex form. And that is, well, here, sorry, it's labeled as S of x. So we're going to say S of x equals A times x minus h squared plus k. And plug in all the components. A is -5, so that hangs out front. X minus h, which is -4. Put that in parentheses. Don't forget the square. Plus k, which is 2. Just nice to put parentheses in everything. You don't have to put parentheses on the -5, but you can if you want. All right. S of x equals -5 times x plus 4 squared plus 2. There it is. Vertex form. We got it. Okay. Next is x-intercepts, and this definitely doesn't factor. So here we'll use the vertex form to find the x-intercepts. So just looking at it, we know it doesn't factor. Or maybe I know it doesn't factor, right? So I'm just letting you guys know. So we'll use the vertex form. So -5 times x plus 4 squared plus 2, set that equal to 0, and then move that 2 over, and you get -5 times x plus 4 squared equal to -2. And then you're going to divide by -5. So divide by -5. And then you get x plus 4 squared equals a positive 2/5. And then you square root both sides. Ugly mess here because you're square rooting a fraction. So you get x plus 4 equals plus or minus the square root of 2/5. All right. So I do have Desmos up to show you guys. We can type this in. I can do the square root of 2/5. And we'll do this to 2 decimal places. That's fine. It is 0.63. So it's going to be plus or minus 0.63. Subtract that 4 over, and we get x equals -4 plus or minus 63 cents. And now you have your two answers, -4 plus 0.63, -4 minus 0.63. So I think the first one, -4 plus 0.63, -4 plus positive 63 cents is a -$3.37, I believe. Just double check that here. Plus 0.63. Yep. And then -$4 minus 63 cents, -4.63. Here's my x-intercepts, ugly as can be, but it works out. And you can change them to coordinates if you want. All right. Y-intercept is always nice. We let x equal 0. That means we come back, look at the original function. If you plug in 0, that's 0, that's 0, and you're left with -78. So this means that S of 0 is -78, which doesn't fit in our graph, but we'll just make it up as we go. Okay, so plot the vertex, -4, 2, 1, 2, 3, 4, 1, 2, right here. There's my vertex. My x-intercepts, we found them, -3.37. So if this is -4, -3.37 would be somewhere around here, and -4.63 would be somewhere around there. And then my y-intercept of -78 is somewhere down here, right? All the way down there. All right, we don't need to worry about that though, as long as we have our 3 points. The vertex, a point to the left, a point to the right. Okay, and connect. There we go. And then everything else comes naturally. -infinity to infinity. And then range, since it opens down, we start at -infinity, stop at the k value of the vertex, which is 2. And since it opens down, it has a max at y equals 2. And yes, you can draw the axis of symmetry, which cuts straight through. That is x equals -4. All right. I think that was all of that. Okay. We'll make this video 2 parts. I know that's a lot. So take a break on this one. And next, we'll start with applications. Okay.